I wanted to introduce you to Rick Dunning. He's an IP attorney here at Shepherd Mullen. He's actually hosting tonight's event. He's just going to have a couple of words. Thanks.
Yeah, thanks for coming. It's good to be here. I've been, excuse me, looking forward to this for a while. I've got an interest in blockchain photography. How's that? So I'll be your patent attorney tonight. Start out with that. I just want to say a couple of quick things about the firm and about me. More. So Shepherd Mullen is a venerable global law firm. Venerable is founded in almost a century ago in Los Angeles. Since then, it's expanded and grown and prospered almost every year. It's a general practice firm, meaning it has attorneys that practice in almost every area of the law, from entertainment to IP. So I'm in the IP division. I'm a patent attorney and a double electrical engineer. I started out designing satellite communication systems for NASA and radar and sonar systems. As a patent attorney, I've worked mainly in kind of double E stuff, CS stuff, computer hardware, software. I've gotten to step out of that box a few times to chase counterfeiters around China, shut down some gray markets here and there around the world. But mainly a patent attorney. And I have had a chance to dabble in some of the blockchain, cryptography, and so on. I've been following Ethereum for a while. So I've been looking forward to this program. So on with it.
Thanks so much, Rick. And if anyone wants to speak to Rick after, we've got like half an hour networking after the panel. Thanks so much.
I should mention I brought some business cards, and
they'll be out on the
they're a
table.
little larger than usual. Mine are in Iowa, so they're printed on index cards. Enough room for pictures.
And so now we'd just like to show a couple of our broadcasts that we do. The first one is Silicon Valley ICO Watch.
Hello and welcome back to FinTech Silicon Valley ICO News Watch. My name is Ruslan Salis, and I bring you the highlights of what's happening in the crypto and blockchain world. So without further ado, let's dive in. So today in the news we have a blockchain betting platform that's doing well. We have the CFA Institute adding blockchain and crypto to its curriculum. And finally, we have some crypto ads coming back to Google and Facebook. Let's jump into the news. Augur, one of the first ICOs and DApp on blockchain, has its prediction betting platform up and running and seems to be gaining some traction. Users are betting on various topics like crypto prices, the US elections, controversial US stocks like Tesla, and drumroll, Game of Thrones casualties, of course. Next, the CFA Institute. In further evidence of Wall Street adoption of crypto, the CFA Institute is now adding topics on crypto and blockchain to its curriculum next year. The CFA Institute administers exams and certifications which are extremely sought after by investment professionals. And then finally, we have some crypto ads coming back to Google and Facebook. Coinbase was in the news last week with crypto ads coming back to Google and Facebook after they were banned earlier this year. They also launched a crypto custodial service for institutional funds and did acquisitions that allow them to list security tokens on their exchanges. Well, there you have it. I will catch you at the same time, same place next week. And make sure that you have subscribed to the newsletter. Catch you next time.
Thanks, Liz. And we've also got our crypto news from Adam.
What's up, y'all? Welcome back to the Silicon Valley Crypto News. My name is Adam Gerardovec, but you can call me Adam.
Hello and welcome back to FinTech Silicon Valley ICO News.
Apologize for that.
Sorry.
And I am bringing...
I'm here with FinTech Silicon Valley, and every week we always give you 3 things. We give you 2 lines of news and 1 bit of law. So since it's July 23rd, we need to start jumping into things because we have a lot of action to talk about this week. So that first line of news is going to be coming out of just straight Bitcoin. So on July 17th, it just spiked up. And then by the time July 23rd hit, we find that each individual Bitcoin is hovering around $7,500, which is a big improvement over the past 6 months. So the second line of news is we have a Singapore e-government service provider called Princeton Logic. They just announced that they now have a cross-border blockchain service that they're providing to help speed up efficiencies with trade. So that should be a very cool thing, and it should be interesting to see how it progresses. But that one bit of law I give you every week is going to be talking about trademarks. Because now we're in a new emerging industry with blockchain. We have all these companies who are trying to change the world, but they need to raise money first. Another thing that they need to think about, though, is protecting their rights and protecting their brand. So if you're a blockchain company, you need to trademark your brand and trademark your mark. So when you do the database search to check out registered trademarks within the United States, you need to do that search to see if there's any confusingly similar marks, but you also need to do a common law search for unregistered trademarks. So make sure your attorney doesn't forget to do that too. So with that, that was your 2 lines of news and 1 bit of law. So I'll see you next time. My name is Adam J. the Lawyer, and I'll see you later.
Thanks, Adam. And now I'd like to introduce you to our very special presentator tonight. Sorry. Pavan, he's actually done a presentation for us last month and everyone absolutely loved it. He's very good. And of course, if you do need trademarking, you're going to speak to Rick, who introduced himself earlier. So I'm going to pass it over to you, Pavan.
Thanks, Patty.
Thank you.
Hey guys, thanks for coming out. Really appreciate you coming. If you didn't get a chance to come to the previous talk, it's on the FinTech website, the FinTech Silicon Valley YouTube site. So you can catch like an introduction to Ethereum. I will go through it a little bit, but we'll go deeper right into the code soon. All right, so let me just jump back here. All right, so we'll go into an ERC20 contract soon. So after this talk, this will be you, right? You'll be all cool, walking away from an explosion, right? I think I can get across an ERC20 contract to you guys in this talk. So about me, I taught a blockchain developer bootcamp called Study the Blockchain. I also teach at Berkeley Extension. I taught at Rutgers, General Assembly, mostly web and mobile development and data analytics. But I got the chance to teach dApps and Ethereum development, and that was a lot of fun. Speaking of Blockworld, hopefully some of you are coming. So I'm leading a workshop there, did a TEDx talk, and I was CTO of a healthcare startup back in the day. So I basically said this is what I've taught. So we'll just jump right in. We'll go through some basics first before we jump into the contract. So I don't want to assume anything. So first off, what's a database, right? It's a program, it lets you store data, right? And it lets you get the data, and it lets you update the data and change it. So that's a database. And if you're wondering, like, why are we talking about a database, right? Well, Ethereum is essentially a database. So I wanted to make sure that was like, taught. So a database runs on a computer. It's software like Microsoft Word, essentially. And people, websites, apps, you connect to it and you get data and you update the data, right? That's all it is. Databases are complex. No, they're not. They're really simple, right? They're super simple. So if you've ever used Excel or a Google Sheet, you understand how a database works, right? So like over here, we have an ID column, and all the programmers in the room, like this is a primary key, but if you understand what a number is, right? Like a unique number. That's what an ID is right here. And then so over here for this first row, it's pickles. And then there's 1 pickle in the refrigerator, right? And the unit is a jar, right? In a database, right? Keep in mind this right here. In a database, it looks like this, right? And that's basically the same thing, right? So Google Sheet, right? And this is Postgres, SQL. But I mean, it looks the same thing. Sure, it's a little bit more complex to put it inside of a database, right? You have to use a language called SQL, but it's literally the same thing. It's pretty simple. So typical databases are MySQL, Postgres, Oracle. These are relational. There are non-relational typical databases, but whatever, right? These are databases, and these databases, they organize the data in a relational way, meaning the data looks like this, rows and columns, right? And so this is, when people say centralized, this is what they mean, right? This is what a centralized system looks like. And typical databases are almost always centralized. They're almost always centralized, meaning the databases here and people and users and apps, they connect to them. So like all of these red boxes here, are people, are users, are apps, or websites that are connecting to the database, right? And then displaying it on the screen of the user. And what about decentralized? When I say decentralized, I also mean distributed. They're both like the same word. Distributed, decentralized, same thing. In a decentralized system, the database, it's not like in a central location, right? It's like everywhere. It's spread across the world. And I think Ethereum has around 1,500 nodes spread across the world, mostly in the United States. So go USA, right? We have the most. I thought it was China, but surprisingly, it's us. So you'll have a lot of nodes that basically have Ethereum, that have the database like on their system. Not all nodes have the entire database, like because you can run an Ethereum node on your phone, and you obviously can't have the entire database on your phone. When that happens, like the developers of that node basically, use some innovative strategies to basically make it so that you can access the network. But essentially, the only thing you have to understand here is that this is more distributed. When it's decentralized, it's distributed, right? Questions so far? Anyone? Any questions? Anything? All right. So, what's a network, right? A network, it's things or people that are connected together. So that's all it is, right? And then network examples, right? You have a bunch of people, they hang out like you guys did earlier today, right? That was networking, right? Right, between people. You could do that in a private Facebook group too. Well, you can have a bunch of phones that are connected together, and then that's a network of phones, and you could transfer calls between phones, right? I mean, I guess it's less common nowadays, but like if you've ever had a conference call on your cell phone and you dialed someone in, right? That's like a network. You could also have a bunch of computers connected together, right? You could have a network of computers. And that network of computers can share data with one another. And so Ethereum is a network of computers, right? With a shared database, right? And also, this network of computers, Ethereum, right, can run special code. That special code is called smart contracts. So again, right, Ethereum is a network of computers, right, just computers connected together that have a shared database, right? A database is just a program that can get and update data for you, and it also runs special code called smart contracts. That's it. That's all Ethereum is, right? And then, so this shared database, it's decentralized, meaning it's distributed, right? It's not in one place. It's like in many other places, at least 1,500 plus places. If you see the other talk, there's a map I have in the other talk of all the nodes around the world. And the database, like what does it contain? It's not foods in a fridge, it's transactions, right? This database, this Ethereum database on these nodes spread across the world contains transactions. So these transactions can be between people and from people to contracts, right? So that's basically the transactions right there. So transactions between people. Transactions between people. What does that mean, right? So raise your hand if you've ever sent someone Ethereum or received Ethereum from someone. Right there. All right, awesome. Jeff? Yeah, so Jeff, what did you need to use to be able to receive or send Ethereum to someone?
Well, just need my wallet software connected to the network.
Perfect, right? So Jeff said he needed a wallet connected to the network, right? So what is a wallet essentially? A wallet is an address, right? You have an address, you have a private key, and you have a public key. We won't go too much into it, but as long as you have an address, right, in a wallet, you can receive Ethereum, and you can send Ethereum to someone, right? And that makes sense, right? Because you've all gave money to someone at some point in your life to get something, right? Or someone's given you money to get some. Hopefully, right? That if that's not happened, then you're an alien, right? But the next thing, transactions between people and contracts. It's kind of weird. This whole concept's really weird, unless you've used a dApp before, right? Has anyone used a dApp? Raise your hand if you've used a dApp, Jeff. That's pretty good, right? So you've used a dApp, so you've had to use a wallet, right? You still need a wallet, right? You still need a wallet. You still need an address with Ethereum in it to basically transact between a contract. And it's like hard to understand. It's like how can I give money to a contract? Well, what do you need to get money? What do you need to get Ethereum? You need an address, right? Contracts, Ethereum contracts have addresses, right? Ethereum contracts, the code has an address. Freaking awesome, right? How amazing is that? The contract has an address. So you can transact between your address and the contract address. That's huge. It's so cool, right? You don't, like, if you've ever used a payment network like SendGrid, or, I mean, not SendGrid, that's email, but like, I'm blanking on the thing. What was it? Venmo, PayPal, like, if you've ever connected to something, Stripe, that's what I was thinking, right? If you code an application, you use Stripe's API, and now you can accept credit cards, right? And with Ethereum and dApps, there is no Stripe, right? Your code can just take payments. It's insane. So what's inside of an Ethereum transaction? So what's inside of an Ethereum transaction? You have a nonce, and a nonce is basically how many transactions are going out. I mean, it's basically a number that's never used again, right? But if you have only one transaction going out, it starts at 0. The nonce is 0. If you have 2, then the second nonce is 1. Then you have the gas price. That's like how much the transaction is going to cost. And you have the gas limit, which is how much, like the max amount that the transaction is going to cost. If the gas limit isn't set, that means you're actually deploying a contract. It'll assume that you're deploying a contract. And then value is basically, oh wow, is it back? That's okay, I'll just pretend that you guys still see it. Is it back?
It's Jesus.
What's going on?
It's a phone call or
It's a phone call. Well, again, what's inside of an Ethereum transaction? All right, do nothing and things work, right? What's in an Ethereum transaction, right? We said nonce, right, which is the number of outgoing transactions, right? If it's just one transaction, it's 0. It's a 0 nonce. If it's 2 transactions, the second one is 1. The gas price is how much the transaction is going to cost. Gas limit is the maximum you're willing to spend on the transaction. And then if it's not set, the gas limit's not set, it's going to assume you're deploying a contract. Value is how much Ethereum you're actually sending, right? It's how much you're sending in the transaction. And data is interesting. It's like, let's say you're calling a specific function in the smart contract. It's specified inside of data, right? And usually when people are doing this, you don't really think about it, right? Because your wallet's handling it for you. Your wallet's sure, you can write code to send a transaction, and developers do that, but if you have a wallet, your wallet's handling this for you. If you're using a dApp, then the dApp's handling this for you. So again, what is Ethereum? Ethereum is a network of computers connected to one another that runs special code. Special code is called smart contracts. The code of a smart contract, like, anyone can anonymously create a smart contract and deploy it. If you've ever deployed a website anywhere, right? If you've ever deployed a website, or hired someone to make a website for you and deploy it, then they had to like make an account on AWS, right? Or make an account on DigitalOcean or Linode or some service. And then they had to give them personal information and then put credit card information down, and then it gets deployed, right? So they know your identity. They have everything about you. But with Ethereum, no personal information is needed. All you need is a wallet. And you can anonymously create like an address. You can anonymously create an address. Matter of fact, you don't even have to be online to create an address. it's nuts, right? So it's so easy to deploy code on this. But once you deploy code, no one can change it. Not even you, right? Not even the person who deploys the code can change the code. That's the difference. It's immutable. And then anyone can see it for the most part. I say the most part because sometimes it's hard to see the code, right? Unless the developer of the contract kind of like opens it up a little bit, right? Sometimes you have to dig deep to kind of see the code, right? So smart contracts, right? Anyone can run smart contracts. Like anyone can run any smart contract out there. And then the smart contract lives forever. I mean, as long as the Ethereum network lives, right? If like somehow all the nodes disappear, then yeah, I guess it doesn't live forever. But I mean, it's a low chance of happening. And then in most cases, it's very trustworthy. I say in most cases it's very trustworthy because it depends on the developer, right? If you're using a dApp, make sure the code vets out. Because the code could just say like, as the owner, I can take anyone's money, right? You can write that in. You can write code in that says like, as the owner, I can take any money out, right? That someone deposits in. So the different types of transactions, right? We talked about it, like between people, like people can transact with one another. And then if you deploy a smart contract, that costs money. Like you can't just deploy smart contracts and it costs money. Sometimes, and it costs depending on how much code you have in there. And then if you call a function in a smart contract, that changes the state of the contract. Meaning if you change any of the data, if there's data that you change, it's gonna cost money. If you're gonna add data, it's gonna cost money. If you're just getting data, it doesn't cost anything. So if you're just trying to get data from a smart contract, it costs nothing, right? But if you change state, meaning if you change data, it costs something. I think that was it right there. So this is the Ethereum GitHub page, right? Raise your hand if you've been there. That's awesome, right? The best way to get better at this stuff is to go look at the code, right? If you want to learn more about this, go look at the code. And hell, go look at the issues, right? There's issues here. Go solve something, contribute, right? You'll learn a lot more than just coming to a talk. But over here on the EIP's list, you'll see right here, ERC, wait 1 second. Yeah, right here. So this right here is what ERC20 is based off of. This, like it's a protocol, it's a set of standards. When someone says ERC20, it's just a set of standards. And these set of standards are actually defined right here, right, in plain English. So it's really cool. And if you're trying to come up with the next big startup idea, right, on blockchain, and you're like, I don't know what to build, right, but I want to build something, come here, go to this page, look at the EIPs. You'll have tons of use cases, all written out in plain English, right here. There's tons and tons of great use cases for blockchain, just sitting, waiting for someone to build. Raise your hand if you've heard of CryptoKitties. Right? That's awesome, right? So CryptoKitties were the first ones to use the ERC20 protocol, right? So maybe you could build something that could be the first use case of one of these EIPs out there. Some of these have never been used. Okay, so now let's dive into the code, but before, any questions? Any questions? None? Just raise your hand if you, go ahead.
When you say it costs something,
Mm-hmm.
what do you mean? What's the value? What's the thing that the cost?
So the question, I'm going to just repeat it for the camera. The question is like, when I say it costs something, what does that mean? Like, what does it cost? It costs Ethereum, essentially, right? So you need Ethereum to basically write to the Ethereum network, or to update data on the Ethereum network. To write to a smart contract or update data in a smart contract, you need Ethereum.
And then who takes the value?
Who takes that Ethereum?
Yes.
Yeah. So part of that goes to the miners, right? It goes to the miners, right? It goes to the network to verify the network, to verify the blocks. Transactions are in blocks, and the blocks need to be verified. The miners do that by running running their mining equipment, right? Yeah, so that's where the money's going.
Got it.
Yeah. Any other questions? Yeah, right there.
Why is it called gas price and gas limit?
So someone wrote it. So wait, let me restate the question. Why is it called gas price and gas limit? My answer: someone wrote it that way. Yeah. So sorry, but if I don't know any more than that. What was the other question? Someone raise your hand. Go ahead.
What's the difference between ERC and EIP?
What's the difference between ERC and EIP? So, it's a really I don't even know what ERC stands for. Yet like I can code it out.
Ethereum request for comments.
Ethereum request. What was it?
Comments.
Comments. Ethereum request comments. Awesome. By Rick, the attorney. Awesome. Thank you. The attorney knows more than the developer. That's awesome. I'm gonna hire you. Right. And EIP. You wanted to say EIP stands for Ethereum proposal. Ethereum something proposal. What was it? Improvement proposal. Thank you. Right. I mean, like, so some of these haven't been actually released yet, right? They're still voting on this. There's actually, I forget the number it is, but there's one on subscription payments. Because subscription payments you can't do subscription payments right now. Meaning, like, for me to just take money out of your account automatically, I can't do that right now. But they're voting on whether they should put that into the network or not. We'll do one more question before we dive into the code. Go ahead.
How do you know what to set the gas price and gas limit at?
So your wallet should just do that for you, right? And then if it fails, you can increase it. Yeah.
What about when you're writing a new smart contract? When you're publishing a new smart contract to the network?
Okay, so let me repeat that question.
Sure.
Like, when you publish a smart contract, how do you know what the gas price should be, right? It's weird. Like, you just kind of set it and then hope that it works, right? And there's like standards online. There's standards online, like, I forget the number exactly, but you set it to that number.
Does it change frequently?
Yeah, based on the network usage, right? It's a network, right? There's no set number, right? So you just set it to a number that people agree on online, and then if it doesn't work, then increase it. Yeah. Right, it's like eBay. Right? Okay, so let's dive into the code. So this will be Solidity, but first, before we dive into this right here, in 15 lines of code, you can build your own token, right? Your own token contract, because of libraries out there, right? It's a lot more code than this, because I'm using the Open Zeppelin library. But before we dive into the code, let's go over some concepts first. So just jump in right here. Solidity is a programming language for smart contracts, right? There are other ones, Serpent and Viper, but Solidity has the most traction, the most documentation. A lot of people use it. Stack Overflow questions. So a contract in Solidity looks like this. This is a contract. What's the name of this contract? Anyone? Sample, right? Sample, right? You know Solidity already, right? So it's called Sample. If you've ever worked with an object-oriented programming language, right, then it's going to be very straightforward for you, right? It's going to be extremely straightforward for you. If you haven't, it's not that hard, right? So the name of this contract is Sample, and so usually when you make a smart contract, you specify this above the contract. So you specify this right here. And this tells the compiler, right? The compiler, the EVM. When I say that, that compiler, right? It's on all the nodes on the network, right? All the nodes across the world have this compiler, and it's going to run version 418, and this thing right here means keep trying new versions of Solidity, keep going up, right? Until it breaks, and then use the version below that. And then skip version 0.5.0. Why is like this? Someone wrote it like this, right? That's it. Questions about this? Yeah, go ahead.
So you said there were a couple, I'm sorry if I'm using the wrong word, languages for smart contracts, Viper, etc. How does that relate to this occurring within Ether or Ethereum, and then something like EOS, which is another platform for smart contracts?
Yeah, so the question is, there are a couple of languages, and how does that relate to Ethereum and EOS, right?
Yes.
Yeah, so, I've never really looked too much into Serpent and Viper. I tended to talk on Viper. I think by the person who writes it, who makes it. It was pretty cool. It's going to work this. I mean, like, you're still going to need Ethereum. It's going to work the same way. Essentially, you're still going to need Ethereum to write, add, and update data to a smart contract. Right? It's just going to be different syntax. That's all. And EOS, I haven't dived too much into it. Is it proof of work?
It's a delegated proof of stake.
Yeah, it's delegated.
DPoS, delegated proof of stake.
There's like 21 nodes.
It's
Okay.
the smart contract language is written in C++.
Okay, it's in C++. Interesting. Yeah, I'm not sure how it would work exactly, but I'm assuming you're going to need some kind of you're going to need EOS to use it. Yeah. Okay, so going into the next part right here, right? So we will get into the smart contract part. I just want to go over this stuff first, otherwise it'll be hard to understand a smart contract. So in smart contracts, there are UINTs, unsigned integers, and unsigned integers are basically they're positive numbers. They have to be positive. They can't be negative. So basically, in your code, you'll specify unsigned integers like this right here, and this is actually code from the ERC20 contract right here. This one line right here. It sets the total supply. And you don't want usually you don't want numbers to be negative, right? Like in a smart contract.Maybe there could be a use case, but usually you want your numbers to be positive. So if you use UINT, right, it's like a shortcut for UINT 256 in Solidity code. So when you see UINT, it's UINT 256. And then once this code right here on line 5, total supply is initialized to 0, meaning if you just write it like this, your code assumes it's 0, right? When you write it like this. All right, so you saw that number, right? UINT 256. So what does that mean, right? What does the 256 mean? UINT means it's a positive number, but what does the 256 part mean? So we'll go to UINT 8 first. So the max value of UINT 8 is 255, right? And the way to get that is 2 to the power of 8, right, minus 1. So 2 to the power 8 is, I should have wrote this in 1 sec. So 2 to the power 8 is 2 times 2 times 2 times 2 times that. So you're basically just multiplying 2 8 times by itself, right? That's what 2 to the power 8 is. And you get 256. You subtract 1, you get 255. So this is the max UINT 8 can be. And the min value is 0, right? So if UINT 8 is 255, then UINT 256 is 2 to the power of 256 minus 1. Huge number, right? A huge number. I think that's more than the amount in the universe, amount of atoms in the universe. I could be wrong, right? But it's really up there. It's a huge number. So that's what a UINT is, and that's what the 8 means right there. And then, let's see. Okay, so right here. So we'll talk about what an overflow is. An overflow is very important. In Solidity, right, the max a UINT 8 can be is 255. That's the max it can be. So what happens when you add 1, right? What happens when you try to make it go to 256? Well, it becomes 0. And that's certainly not what you want, right? So if you're saying something's UINT 8, you're saying the max can be 255, and if you accidentally add 1 to it, it actually becomes 0, and that's called an overflow, and it's caused a lot of bugs in people's code. So there's a library called SafeMath that Solidity smart contracts use to basically prevent overflows like this and underflows. Okay, so going back over here. So there's a special data structure called mapping in Solidity, and it's very similar to an object or a hash, right? So if you Ruby people, hashes, JavaScript people, objects, right? Python people, dictionaries, right? So we have a mapping right here. So over here, this mapping, what's the name of this mapping? Age, good, right? Whoever said age, good job, right? It's age. And basically it's a key, right, of a string data structure pointing to a uint8, which is a number, which is an unsigned integer, force positive, max 255, min 0. So over here, we're saying that we're having a key called Justin Bieber, right? And his age is 224. Right, and then over here we have the oldest person in the entire world, Kane Tanaka, and max age, we have this age of 115. So uint8 is very fitting for this. Why is uint8 very fitting for this, anyone?
Who's gonna go over to? No one will be 255.
No one's gonna be 255, right? I guess, hopefully maybe in the future, right? But not now, right? Not for the foreseeable future. No one's gonna be 255 or 256. Yeah, go ahead.
So who will be charged if we are adding more key value pairs into the mappings? Like, is it the smart contract deployer or like the one who try to invoke?
Great question. That's an amazing question. So who's gonna be charged money if you're adding more key value pairs into a mapping, right? That was a question. So the answer is the person running that function. So the user. Yeah, the user. Yeah. Great question. Was there another one? Okay. All right. So, and these are some keywords that are very important. They're used all over the ERC20 contract. So they're function modifiers or modifiers. So there's public, and public means that this variable or function can be accessed anywhere by anyone, right? That's what public means. And there's private. Private means that it can be only accessed within the contract. And these are terms that are very common in programming. So it's private meaning you can only access this thing inside of the contract. And then you have internal. If something has internal on it, then it can be only accessed inside the contract, similar to private, but also to contracts that extend that contract. So if there's a contract that extends a contract, then it can use anything named internal. But if something's private, it can be only used inside of that contract, not by anything extending the contract. And then there's external, which means that variable can only be accessed outside the contract. And then you have view and pure. So view and pure are interesting. What they mean is that we're not going to update the state of the contract, right? We're not going to update any variables, right? State and variables, same word, right? Synonyms. So we're not going to update any state in the contract, variables in the contract. So when you say view, views can actually access state. So meaning they can actually access variables in the contract, but it never modifies it. Pure doesn't access or modify anything in the contract. So a pure function could be like a function to calculate, to convert Kelvin to Celsius, right? That would be a pure function. It wouldn't be using anything inside the contract at all. Questions on this? Yeah, go ahead.
Can you give us some examples about like when to use the external keyword?
Yeah, so so if you're gonna say external, it means like it's more of like you're communicating something to anyone using the smart contract, right? That the only use case that you see is outside of this contract. You don't see a use case for this function inside the contract, right? It's more of a safeguard, right? Like it's almost like why would you ever name anything private, right? Like why not just make everything public? But it's kind of like a safeguard for you, right? It's almost like a security measure. You're saying that the only use case for this is outside the contract. So I don't want any chance of using the inside of the contract because it'll throw an error if you try to use something inside of contract that's named external. It's more for you as a developer.
Like why do we need to make that distinguish? Why do we need to distinguish those two?
It's just for you, right? Because you literally cannot use it inside of the contract. You can only use it outside of the contract. So any app that's using that smart contract or connecting to it, they can call it, but the contract itself can't call it. Yeah. Yeah, I know it's hard to imagine, but once you see more examples, you'll see use cases of external. And this is the last one. So this is a function inside of Solidity. So it's pure, right? It's pure, so does this modify state? Does this modify variables in the smart contract? No, right? It doesn't modify anything, right? And so what's the name of this function? Ret a number, right? That's the name of the function. It has no arguments, right? It's public, so it can be accessed anywhere. It's pure, so it means that it's not even accessing state. It's not modifying state either. And then it's returning, what's the data structure that it's returning? UINT8, great, right? It's returning a UINT8. So it's returning 3. So, I mean, this doesn't really do anything, this function, but it just goes over the concept and the structure of a function and solidity. So now that we have this, gone over, let's jump into the code. So this is tutorial token. You all can really run this app. So I have the app running over here. We're not going to go into the Web3 HTML, CSS code. But this is what the app looks like, and you can clone this on GitHub. It's open source on the Open Zeppelin website. So over here, this is a smart contract between this DApp, right? And so we're using version 4.17, and over here we're importing in the standard token from Open Zeppelin's library. And so this has become very standard to use when you're creating a token on the network. And this is literally all the code you need to basically create your token. So the name of this token is tutorial token. The symbol is TT. It has 2 decimals. Now, it comes with 2, but you should probably change this to 18, right? That's become the standard of how many decimal places your token should have. And then the initial supply is 12,000 right here. The initial supply is 12,000. So you'll see all these variables inside a standard token. Now this right here, this function, I just deleted all of that. So this function on line 11 right here is a constructor function. So when this contract is deployed, right, this function will run, but only once. That's it. Right, on deployment. So this function right here will run once on deployment. This is a constructor function, and you know it's a constructor function because it's named the same as the contract. There's a new standard where it's called constructor, not this, but it's still a constructor function. And you usually just make it public. And over here, we're basically taking this initial supply variable of 12,000, and we're updating a total supply underscore variable. This variable lives inside I think basic token, and you'll see that soon. Over here we see the initial supply going to like a mapping. Balances is a mapping. Balances is a mapping of an address to a number, right? So this line of code right here, does anyone want to venture out and take a guess of what this line of code's doing? Go ahead, raise your hand.
It's setting the initial supply to the balances of the person sending the tokens.
Perfect, right? Excellent. That's exactly it. So what he said was it's taking this initial supply of 12,000 and it's giving that to the person deploying the contract. So msg.sender is the address of the person connected to this function. Right? msg.sender is the address of the person connecting to this function. And who would this person be? It's the person deploying this contract because this function runs only once. It runs only one time, right, on deployment. So the person deploying this is that owner. The person deploying this gets all the money initially, right? Initially, right? And then there's an ICO contract that they can run, and then they can send some of that money to the ICO contract. Questions about this right here? Go ahead.
Is the symbol unique across the entire network?
Is the symbol unique across the entire network? Right? Is this symbol unique? No,
Yeah.
It's not.
It's not.
No.
So you can have multiple TT tokens.
You can have multiple TT tokens. Yeah. But they'll all have different addresses. Right? Every token contract will have different addresses. Yeah.
So somebody can create a EOS token, for example.
Don't do that. But you can. Yeah, but you can. You can do that. Yeah, you can. But don't do it. Yeah. Question about
Is balances an array?
Oh, so the question was is balances an array? It's balances is not an array. Balances is a mapping, right? So it's gonna look like this. Pull up the mapping example. I'll get to that particular code. Here we go. So balance is going to look like this. That's what balances looks like, right there. Good question. We'll do one more.
I have a question.
Yeah, go ahead.
Can you also send tokens to a contract address?
Can you send tokens to a contract address? Yeah. So you can send tokens to a contract address, but here's the thing. That contract needs to have the ability to kind of ingest them, right?
Is that in constructed?
They would have to write a special contract to do that. Not ERC20 is not that contract. There's another I don't know what the number is off the top of my head, but there's another standard to be able to ingest tokens, right? And you're not really ingesting them, right? This contract can't hold on to other tokens, but it can hold on to addresses of other tokens, right? Inside of the data structure, right? And then it can modify state in that contract, in the other contract of those tokens, to say that my address has the ability to take coins from this balance. Yeah, it's a little bit complex, but you could totally do that. One more question. Go ahead.
Is there a way to deploy the initial supply to people who are not the original?
Yeah, absolutely. Yeah. So the question is there a way to give this initial supply, like split it amongst other addresses, right?
Or not? Maybe. What about all addresses?
So I'll do the first part first,
Okay.
right? So the question is, can this initial supply be split amongst multiple addresses? Yes. You just have those addresses over here, right, somewhere, and then you could split it here somewhere, right? But if you want to give this initial supply to all addresses, it's a much bigger problem. You would have to know their addresses. We would have to know their addresses. I mean, what you're trying to do is an airdrop, right?
Yeah.
If you want to do an airdrop, I mean, like earn.com can help, right? Earn.com has like an airdrop feature. There's a couple services out there that will do airdrops for you. If you want to run your own airdrop, like you'd have to have the addresses somehow. Yeah. Sorry guys, I'll be afterwards and I'll answer more questions. I just want to move on a little bit. So over here, tutorial token is extending standard token. So let me open up standard token. This is standard token. This is from the Open Zeppelin library. This is all on GitHub, right? So this standard token is extending ERC20 and basic token, right? ERC20 and basic token. So I'll open up standard token in a second. The reason why I wanted to open it up right away was because tutorial token is actually extending standard token. So I wanted to just show you this is standard token. And standard token is extending ERC20 and basic token. So if I take a look at ERC20, right, it's this. And this doesn't look like much code at all. What this is called is an interface. This is an interface. And it's basically a set of standards, right? Like you should use these functions. And ERC20 basic is also an interface, right? Why is it written like this? Ask Open Zeppelin, right? They're the ones who wrote it. But the meat of the code is in basic token. So let me open this up right here. So the meat of the code is right here, and this is a library, right? SafeMath is a library, and it prevents overflows for UINT 256s. If you wanted to prevent overflows for UINT 8, you just change the number from 256 to 8. So we got a mapping of balances, right? So this is what balances looks like, right here. We use balances as keyword in tutorial token over here, right? The way we're getting this is, right here, from this line. So this stores all the balances, right, for the entire contract, for all of the addresses. And then we have total supply. Remember when we set total supply in the constructor function? Right here. This is total supply. We're setting the initial supply of 12,000 to the total supply variable. This total supply variable lives inside basic tokens right here. And then over here, if we wanted to get the total supply, right, we would just call this function. How much gas does this cost? How much gas is getting the total supply cost? Is it 1 million? 10 million?
Zero.
Zero. Why is it zero? Why does it cost only zero?
It doesn't.
Reading data.
It's just reading. It's not modifying state, right? Remember, if things only cost money if it modifies or adds or updates state, right? But this doesn't update state. Matter of fact, we even makes it super easy to know because it's a view. If something's view or pure, it doesn't cost anything. So this is how we get the total supply back. Over here, this is the transfer function, right? This is what wallets use, like web wallets or any wallet. So transfer, so it takes an address called to and a value, and then it returns a Boolean of true or false. And basically, right here, this is like an if statement. It's an if statement. I mean, like there are if statements in Solidity, but you shouldn't use them as much as a require, because require will like terminate right after line 32. It will terminate right there, and it won't go on. Whereas an if statement will go on. So you'll see most people use a require statement. Can I get a time?
7:52.
7:50. Oh, I mean, how much time's left?
10 minutes.
10 minutes. Okay, cool. Thanks. So over here, so with the so over here, required to. What this means is that this address passed into this function cannot be address 0. So address 0 is interesting. What address 0 does is it's like an Ethereum address that looks like this. You can send money to it, but then no one can get it, right? So what that does is it just says don't do that, right? Please don't send money here, right? Because then no one can get it. And then over here, this just checks whether what you're sending is like you have that money, right? Like is the amount of money you're sending, right, less than or equal to how much money you have? And what is MSG.sender? Your address, right? MSG.sender is your address. It's the person's address that is running this function right here. So then over here, this right here, what this does is it updates your balance. It updates your balance. So if you're wondering like what is .sub, right? .sub is short. It's short for subtract, right? It's just subtracting the value from your balance. So you can update a balance by doing this instead. You can just do -1, but then you risk overflow, like overflows. So that's why people use .sub from the safe math library to prevent overflows. And then over here, right, it's adding value to whatever address, to the balance of the address that you're sending the money to. And then emit transfer, this looks really confusing, but all this is saying is like, it's an event. It's an event. And we'll probably not get to this, but any dApp or wallet that's connected to this contract, once line 37 runs, it'll get like a message and then to like update the UI to let people know that, hey, the balances have changed, right? Go ahead, question.
So the sender in that function right there, how does it protect it to make sure it doesn't get manipulated?
So the question is, how does it protect MSG.sender from getting manipulated? What do you mean by getting manipulated?
To change. So blockchain, I heard, is like very difficult to change, right? It's like all encrypted, right? But the question is, like, if you're able to access this, you could change the sender to someone else. So how does the code prevent this change from happening?
So the question is, how can the code prevent MSG.sender from being manipulated? It's impossible, right? Because if you're connected, the only way to run this function is with an Ethereum address, right? And then whatever Ethereum address you're using to connect to this function to run it is going to be MSG.sender. And then it's going to check how much balance you have, right? Not someone else.
It's specific to the person running.
Yeah, it's MSG.sender is specific to the person running this function. Whatever address they have is what MSG.sender is going to be, right?
Which is the node that's connected, right?
It's not the node. It's just MSG.sender is just whoever's connected to it, right? So if you make a dApp and then someone uses your dApp, right, then MSG.sender is going to be their address. Yeah.
Signature.
Oh, sorry. Go ahead.
I said you would use signatures to prove you're the owner of that address.
Yeah. What he said was you would use signatures to prove that you own the address, and the wallet would do that for you. One more question? Yeah.
So how do users get like unique Ethereum address?
The question is, how do users get unique addresses? The wallets just do that for you, but it's just an algorithm. It's just an algorithm. It just, there's a private key, and it starts off with a private key, runs through the algorithms, and then generates a public key. And that's it. You don't have to be online. Have you ever used Mongo?
No.
MongoDB?
No.
Have you ever used a UUID?
But I mean, like they're all like centralized stuff, right? How do we do that? Like,
it's just it's an algorithm. It's an algorithm, and the algorithm is like really good. It's gonna be very rare for two addresses to be the same. If you wrote your own code to create your own address, and let's just say you chose a private key of 1, which is totally possible, right? You're gonna get hacked immediately, guaranteed, right? But there's a way of choosing a random number for a private key that most wallets use that's very hard to determine, right? So if you figure out a way of reverse engineering people's public keys to private keys, you'll be the richest person in the world, right? All right, going down. So then over here, this function, right, just based on the name of it, what does it do?
Retrieves the balance.
Retrieves the balance, right? Good job, right? It retrieves the balance. So it takes in owner, which is an address data structure, and it doesn't update state. How do I know that really quickly from this word? It's a view, right? Views and pures don't update state at all. So it doesn't cost any money to run this function to get the balance. So it takes in an address, and then it returns the balance of that owner. And so it's going to return a UINT 256. So that's this contract right here, and I have about a few minutes left. So I'm going to just jump into the other bulk of the contract. So these are the rest of the functions. So this is a little bit more complex. These functions are more used by exchanges, right? So there's a protocol. ERC20 is a protocol, and so as long as you follow these standards, then it's really easy to integrate your token onto an exchange like IDEX or like Binance or anything. I mean, you have to pay money to Binance, but other than that, you can do it. So over here, this is interesting. This right here is a mapping of a mapping, right? So the mapping is called allowed. It's internal, meaning anything inside of this contract right here can access it, or any contract that extends this contract can access this allowed variable. And so it takes in an address as a key, and it maps it to a mapping, right? So this mapping right here is an address to a UINT 256. What allowed is used for is to allow you, is to give someone else access to your money, but to a limited amount. So let's say you have 500, right? That's your balance. And you're like, okay, you can have, you have the ability to control 100 tokens, right? And you have the ability to control 100 tokens, right? But only 100. That's what allowed does. And it's mostly used for exchanges, right? If you're wondering like what's the use case, it's for exchanges. And yeah, okay, so transfer from, right? Transfer from. All right, this is different from the transfer function that we saw earlier. It's a little bit more complex, but it's because it's doing more checks, right? Because this is allowing someone else ability to take money out of your address, your balance, right? That's what this transfer from function is doing. And then we have over here the prove function, right? This basically lets give someone lets you add someone to this mapping right here of allowed, right? So you could pass it an address and a number. So if I go down over here to approve, basically it takes in an address and a value right here. It's almost like you're giving an allowance to someone, right? An allowance to your balance. So over here, it updates this mapping. It says, all right, so grab my balance, right? And I mean, here's my address, and here's the person's address that I want to give an allowance to, and this is how much I want to give to them, right? So that's what this does right here. And then going down, this is an allowance function, so it just returns how much of an allowance they have, right? It returns how much this person has access to in my contract. And then going down more, you can increase the amount of money that that person has, the allowance of that person with this function, increase approval. And then you can also decrease the allowance for that person, right? And again, it's like it's hard to kind of imagine like how would I use this with my friends? It's more for exchanges. Exchanges use these functions. Yeah. So let's just jump into questions. Go ahead.
Is that allowance per unit of time?
So going up, allowance is for money, not money. I'm sorry. UINT 256. So it's an unsigned integer, positive number, anywhere from 0 to 2 to the 256 power minus 1.
But does it prevent you from spending your balance?
Does this prevent you from spending your balance?
Your entire balance? Is that what it is?
Well, so if you give someone, let's say you add someone's address into this, right? You call that allowance function or whatever, right? To give someone an allowance into your balance. You still can spend all of your money, right? But that person can spend the amount of money you allowed them to, right? If you spend all of your money, then they can't spend anything, right? Because there's no money to spend anymore. But they have the ability to spend a certain amount of your balance.
Oh, okay.
Yeah. But if you remember back in the balance function, it's not going to allow you to spend more than you have. The balance the transfer function is not going to allow you to spend more money than you have. Other questions? Yeah, go ahead.
There's like a little underscore before some of the variables.
Oh yes,
what
sorry.
Does that mean?
Great. So the question is, what does this underscore mean? It's just a convention that Solidity uses, right? That all arguments should have underscores in front of them, right? So what's the point of that, right? So like the point of that is to differentiate. So you see how this variable right here has no underscore in front of it, and this one does. It's for you to differentiate between things that are arguments and things that are in state.
Okay.
Yeah. So this is like in state, right? This variable called allowed is in state. Other questions? Yeah, go ahead.
So if you accidentally mess up part of your contract and you publish it, and 6 months down the line somebody discovers a critical flaw, what happens?
So if you mess up your contract and then 6 months down the line, and you deploy it, and then 6 months down the line there's a critical flaw, what happens? You have to tell people that you screwed up, right? And then you make a new contract, right? And then you transfer money to all the people that had money before to those addresses. You would have all those addresses, right? So you would know what to do. It would just cost you time and money, and then your token would also go down a little bit, right?
Same answer from the lawyer.
Can you deploy the same contract? Can two people deploy the same contract?
Can two people deploy the same contract? That's the question. Yes, two people can deploy the same contract, but then what's going to be different about the contract, though? Address. The address is going to be different. Yeah. Sorry, guys. Yeah.
Sorry that we have to wind this up. We do have half an hour now for networking, and I wanted to give a round of applause to